Math time. All right, little blue frog. He was still sleeping, but I woke him up. And he says, good morning. So there are a couple of things that you need to do. So once you listen to me for the first little part, pause me and go take care of it. So you're going to do Power Up, page 78, all of the facts, mental math, and word problem. Then you will take construction paper. No, first you're going to take copy paper, or if you have it, like the plain, what Miss Taylor uses in her printer, or if you have plain paper. If not, just use notebook paper. But I have posted 3 different pictures on Facebook that have the different types of triangles that we're going to learn about. And remember a right angle. We look at the angle in a triangle, and we know that that's a right angle. Right? If we find the largest angle and it's obtuse, greater than 90, okay, it would be obtuse. And then if all the angles in there were smaller than 90 degrees, they would be acute triangle, right? But we're also going to learn different things about the sides. An equilateral means that all sides are equal. If 2 sides are equal, it's isosceles. So in this case, I made this isosceles right triangle. This side and this side are exactly the same length. They're 5 inches and 5 inches. And this wound up being a little less than 7 inches. So if I have a triangle that has 2 sides that are the same length, it's isosceles. And in this case, we know it's a right angle as well. Pretty cool. See how smart you are? Okay, and then if all 3 sides have different lengths, it's called a scalene. Can you say that? Scalene? Okay, equilateral, all sides equal. Isosceles, 2 sides are equal. Scalene, none of them are equal. Okay, so you're going to draw those, and I want you to write the word, like you're labeling them, you're classifying what kind of angles they are, because we need to be able to refer back to that. And that's something I want you to keep with you in your math book or so forth, okay? Because we're going to look at it. It says, draw a triangle that is both a right angle and an isosceles triangle, which is what Miss Taylor did. So I used my ruler. Here we go. Let's see if Miss Taylor can show you correctly. It is, if I don't like that, what do you think? Can you see? It is 5 inches. Let's see if I move it out that way. All right, 5 inches by, okay now. What if I do it this way? I should tape it to it maybe, huh? This looks like I trimmed it a little, but that should be 5 as well. Okay, and then you'll match. So I would use your ruler, and I would choose a size, maybe 3 inches, and you make a line 3 inches. Then you make another line that is going to what? Intersect. It'll be perpendicular. Make it 3. And then use your ruler to connect those 2 end dots. And you will have an isosceles right triangle. Ta-da! All right. So that's the first thing I wanted us to do. Next, they want us to do a transformation in congruent triangles. So cut out 2 right triangles, which is what we just did. You are going to draw yours. It's going to look something like that. Whatever measurement you make, you choose. This is 5, 5, almost 7. And I have one just like him. They're twinsies. What do they call those, Twinkies? Anyway, I've got 2 of them, all right? And that's what you're going to do. It says cut out the 2 right triangles. Now place the 2 triangles in the positions shown below. Plan to move one triangle using the translation and a rotation to show the triangles are congruent. Remember that one triangle must be on top of the other in the final position. Write your conclusion. So I have this here, okay, and then they want me to have it like so, okay. So we have these two here. What did I do? Could I flip it? All right, so it says that you could do one or two things. You could do a 90-degree clockwise rotation. Okay, clockwise. And then I could move it over there. So here, 90 degrees. This is very hard to do in the air. So I may have to do like a little video or something to show you, because I have my phone on the tripod and I can't do it. So if you put your two triangles together on your table, okay, and then you take one and you turn it 90 degrees and then 90 degrees, and you'll see how they're all flowing. So if I go from here to 90 degrees. All right, so remember the clockwise, the way the clock hand goes, that's quarter of a turn 90, quarter of a turn 90, and so forth. I want you to play around with that, and I want you to see if we can determine which way is going which way, because that's kind of confusing for when Miss Taylor not being able to show you. I'm gonna find a video, or I'm gonna make one that's just specific so that we can play with the figures and you're not looking at me, but you're looking at the shapes, okay? Good. We are going to go ahead and jump into, I wanted us to do A through C, which is the written practice. Nope, the lesson practice. It's on page 546. It says lesson practice. All right, it says, can a right triangle have two right angles? Here's a right triangle. Can it possibly have two right triangles? No, it cannot, okay? If it did, it would wind up being a square, okay? So, no, you cannot have two right angles in a triangle. What is the name for a triangle that has two sides? Remember, all three is equilateral. The two sides are isosceles. I-S-O-S-C-E-L-E-S, isosceles. All right, so this is an isosceles triangle and two sides are equal. It says use a colored tile to model the translation, reflection, or rotation. So bottom line is you're going to take those little triangles and you're going to play with them, okay? We're going this way, moving. We can flip it. We can rotate it. Right? So that's what I want you to do. I want you to play with those. And then we're going to, on your grid sheet, we're only going to do two problems that deal with this. So I'm looking at number 9. Nope. Which one am I looking at? My bad. Complete lesson practice A through C, and then 1 through 7. Oh, Miss Taylor. Coffee. I need coffee. All right, so 1 through 7 are somewhat word type problems, and I'll go through them just a little bit. As you can tell, I've got people awake in my house finally, so it'll be a little bit noisy, but it's okay. We're used to that, right? Gerald bought pencils on sale for 5 cents each. If he spent 95 cents, how many pencils did he buy? How could I find that? So he spent 95 cents. If you spent 95 cents and each pencil was 5, well, couldn't you just, yes, you could divide. So we are on lesson 78, page 546. Number 1, if I take 5 cents into 95. How many pencils is that going to give me? I'm not going to give you the answer. I've set it up for you. You're going to divide. It's going to come out even, and you're going to tell me how many pencils did he buy. Make certain you label it pencils, okay? We're going to call her Clan. Clan went to the store with $9.12. Okay. Those 12 pennies are important. She spent $3.92. About how much money did she have? So what they want us to do is they were wanting us to estimate around. So what if we said she had $9 and she spent $4? She'd have $5 left, right? Now what if we did it exactly? So on the first one, if she had $9 and she spent $4, yes, she would have about $5 left. Now, what if I put $9.12 minus $3.92? Write that problem down and solve it for me. Make certain you include your dollar sign and decimal point, okay? Good. Pamela listened to half of a 90-minute tape. How many minutes of the tape did she listen to? 90 divided by 2, right? Because half is always divided by 2. So what you're going to do is you're going to take 90 and you're going to divide it by 2, and that's how many minutes she listened to. So you know how to set it up. Do I have to show you? 2 into 90. Then write how many minutes it is. Okay, you can do it mentally. Great. Half of 90, and then write minutes to label it. Okay. 1/4 of the guests gathered in the living room. What fraction of the guests did not gather in the living room? And then what % of guests did not gather in the living room? Okay, so 1/4 gathered in the living room. Okay, so 1/4. They're over there in the living room, sitting on the couch, eating potato chips, I don't know. The question is, what fraction did not gather? Well, wouldn't that be right? If 1/4 is in the living room, where's the other 3/4? Somewhere around the house. Not there. Okay. Then the next question is, what % did not gather? Think about $1. If 25 cents is in the living room, or 25% is in the living room, what's the % that's not in the living room, that it's somewhere else? Yes, 75%. All right, number 5. If one side of an equilateral triangle is 3 centimeters long, what is the perimeter? What about an equilateral? Equal sides, that's right. So if I have an equilateral, this is number 5. If I have an equilateral triangle, I'm going to try to make it look equal. No judging. Dev, stop it. Zane, stop it. All right, so I have 3 centimeters on one side is what it tells me. If I have an equilateral triangle, that means all sides are equal, and they give me the measurement of just one. They want to know what the perimeter is in centimeters. So 3 plus 3 plus 3, or 3 times 3 is 9 centimeters. So I would know that their perimeter, or the perimeter of that equilateral triangle, is 9 centimeters. Then they go a step further and they say, well, what about millimeters? How many millimeters is the perimeter? Remember how many millimeters in a centimeter? 10. what'd you say? 10. Ava, what'd you say? 10. Okay, so my perimeter could also be 90 millimeters. Yeah? Good. All right, number 6. To what decimal number is the arrow pointing? What is the mixed number? Okay, they've got negative again, and they have 10 spaces in between. Now I want you to think about that, and remember, the closer to the 0 is the larger of the negative numbers, so that's why it looks like it's going backwards, but it's not. So if I have 8.9 and then 8.8, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I do this? Let's see. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that is correct. And it's pointing at this right here. Okay. So know that 0 is over there, okay? So then it would be 0, 1, 2, 3, 4, 5, positive numbers. But here, I'm going from 8.8, and I'm going to this point, and this is 8.9 right there. So what is 1 less? You could say this is 8.89. Because technically, this is also 8.90, right? I can put that 0 in there. It doesn't change the value at all. It just helps us manipulate the numbers so that we realize this is the decimal point, and then it goes a step further and says what is the mixed number or the fraction. So you would tell me that it's 8 whole and 89 hundredths, right? Okay, take a moment, make certain you write that on the grid sheet completely, okay? And we'll do number 7, and we'll be finished with math today. If you want to continue on, please do so. If you want to wait and work with me on some of them tomorrow, that's fine too. All right. Half of a gallon is half gallon. Rocket science. Okay. Half of a half gallon is a quart. Half of a quart is a pint. Half of a pint is a cup. A cup is what fraction of a quart? Now remember our little thing, our little picture, my little magnets on the board with the big gallon, right? Then it had the 2 half gallons, and then in each half gallon they had quarts. And inside that quart, how many little cups? There were 4 cups to a quart. So what you're going to do is they're asking you what a cup is, what fraction of a quart. So I know if 1 quart equals 4 cups, and they're telling me now a cup is a fraction of a quart. Well, 1 cup is 1 out of 4, because it takes 4 cups to equal a quart. Yeah, don't let them trick you. I think they just had fun writing that down so you had to read it over and over again. All right, let's do this. Monday,